Hello and welcome to another video of Programming Basics. In this video, we are going to study about the constants and flow control mechanism in Arduino programming. Let's get started with constant. Constants are some of the predefined values in Arduino programming language, and these constants are going to make our code easy to read and easy to write. So constants can be assigned to a variable and we can perform all kind of operation on these constants. True and false constant. A value of 0 is false and a value of 1 is considered as a true. Notice the lowercase in true and false. It has to be in lowercase. High and low constant is used to define the state of a pin. So high is also considered as a logic 1. It is also considered as an on state or 5 volts, while low is considered as a logic 0, off state or 0 volts. Another kind is input and output. This kind of constant input and output is used with the pin mode function to define the function of a pin, whether the particular pin in Arduino is going to be an input pin or an output pin. In our subsequent video, we will see about how to use true and false, how will we use high and low, and how to use input and output in our Arduino programming. Let's look at the control statement, if control statement. It is used to test if the certain condition has been reached or not. If the certain condition is reached, then we can perform some kind of operation, or otherwise we can skip that operation. So the syntax of if statement is we start with writing if, lowercase if, and then inside a small bracket we write a condition, the expression of a condition, and within a curly braces we write all the statement that we want to execute if this condition is met. Let's look at an example. Here, integer value is 5. If value is less than 10, then value is equals to value plus 10, right? So let's evaluate this example. Value is initially assigned to 5. The expression here, 5 is less than 10, which is definitely true. Now, if this expression is true, then we go on and execute the statement inside the if block. If this expression is true, then we go on and execute this statement within an if block. So this will add 10 to a value, right? So this is basically value is equals to value plus 5, and then the final value is going to be 15. Now let's look at another example. In the same example, if we have a condition in an if block saying value is greater than 10, then this would actually be false, right? Because value is initially 5, so 5 is not greater than 10, which means this expression is false and we will skip executing this particular statement. So the value remains 5 after the execution of this block. Now let's look at another statement, if-else statement. So if-else statement is kind of either or decision making statement. If a certain condition is reached, then we perform some operation. If that condition is not reached, if that condition is false, then we do something else. Let's look at syntax. If this condition is met, then we will do some statements within these two curly braces. If this condition is not met, if this condition is false, then we do another bunch of statement within else block, right? Now let's look at an example. Here the value is 5, right? If 5 is less than 10, which is definitely true, then we go on and perform this expression, which is value is going to be 15, right? Now let's look at another condition. So now let's look at extended version of if else statement. The value is initially assigned to 15. If value is less than 10, then we perform this operation. Else if, please note that there is extra if here, else if value is greater than 12 and value is less than 20, then we perform this operation. If it is not the both, anything other than these two conditions will perform this operation, right? So let's evaluate this. Value is 15. 15 is less than 10, which is false. Then we move on to another block here. 15 is greater than 12, that is true. And 15 is less than 20. So this expression inside here is going to be true, which means we are going to execute this block here. right? So we can also keep on adding bunch of other else if statement. So we can say else if value is greater than 20 and value is less than probably 30, then do something else. If value is greater than 30 or value is greater than 50, then do something else. So you can keep on adding else if before you eventually add else. So the value of this expression is going to be 20, right? Because 15 plus 5 is going to be 20. Now let's do a quick quiz. So I want to test the value of input pin. So this is a variable called input pin, if it is high or not. If it is high, then I want to turn on the light. So is this statement correct to achieve this task? So let's pause the video here and think about the answer. All right. So this is not correct, right? So the correct statement would be something like this. If input pin equals to high, then I can go ahead and turn on the light, right? Notice the difference between single equals to and double equals to. So single equals to is an assignment operator. It is going to assign this value to this variable, right? But what we are trying to achieve is we want to compare the value if input pin is high or not, right? So in that case, we want to use equality operator. So this is a comparison operator, and the result of the comparison operator is going to be true or false. So if the value of input pin is high, then this expression would provide me a true value. In that case, I would go ahead and turn on the light. If this value would be false, then I would have skipped this statement. Now, let's look at another important control flow statement, which is a loop. So loops in general are used to perform some task repeatedly. For example, let's say you want to do a task of turn on the light, wait for 5 seconds, turn off the light, wait for 5 seconds, and say you want to repeat this task 50 times. Then the easy way to do that is you want to create a loop and write the task one time and repeat it 50 times, right? So this is the syntax of writing a for loop. For loop has a following construct, right? You write for, and then inside a small bracket, you have an initialization to make, you have a condition to meet, and you have an expression to evaluate. And within a curly braces, you write all the statement that you want to repeat, right? So let's look at an example to get a clear idea of what I mean. So for initialization, so this part, integer int I is equals to 0 is initialization. I want to have a condition I less than 20, and then expression is I plus plus, and then some task. So what this structure is saying is that I want to repeat this task until the value of I reaches 20, right? So at the beginning, I is set to 0, and then I am incrementing I by 1 until it reaches 20. So that's what this expression is saying. And then I do this task until the value of I reaches 20. So instead of doing this, you could also have initialized I to 20 and then check if I is greater than 0, and then you can decrease I by doing I minus minus. So there are different ways of implementing loops. So in all different ways, you have to have an initialization, you have to have a condition, and you have to have an expression. Now, there are other kinds of loop as well. There is while loop, there is a do while loop. So I strongly recommend you guys to go ahead and take a look at a reading assignment to understand how to implement the other kinds of loops. So let's do a quick quiz. What is the result of a value at the end of this loop? So let's pause the video and think about the answer. So the value after evaluating this is going to be 20, right? Because you're initializing a value to 0, and then inside this loop, you are counting I all the way from 0 to 20 with a step of 1 until it reaches 20. And at the same time, I is counting all the way to 20, you are also increasing the value by 1. So eventually, when I reaches 20, value will also reach 20. Thank you for watching this video. Please take a look at the reading assignment section, and I will see you guys in next video.